Hi guys, this is Mr. Pygott here, and we're doing the 2008 question number 2 test. It's table questions. Remember, you have a quiz later on this week, and one of your questions will be table questions. So let's go ahead and jump right in. Notice here we have a table that's in hours and people. Okay? And the very first question, part A, uses a very important word. They ask you to estimate. Okay, what are they asking us to estimate? The number of people waiting in line, the rate at which the number of people waiting in line is changing. Now, they want, if L of t, so let's just be really quick, if L of t is the number of people, L prime t is the rate that people are changing. So when they ask you to estimate the rate of change that people are estimate the rate that the people in line are changing, they are asking you to basically estimate the derivative. So here they want you to estimate L prime 5.5. Now let's just think about it. If you actually were able to graph this, it would look something like this. Okay, it's down here at 0, here it's at 120, and somewhere in here, actually it's horrible, it would look different than this, but whatever. The idea is L prime 5.5. What does that mean? If you were to actually be able to find L prime 5.5, you would be finding the slope of the tangent line. But to be able to find the slope of the tangent line, or the slope at one point, you need to actually have an equation. They're asking us to estimate the slope of the tangent line. Well, we can estimate the slope of the tangent line by finding the slope through 2 points. That's old school slope. y2 minus y1 over x2 minus x1. So we're going to find the slope through 2 points to estimate what we would get if we were to find the slope through 1 point. Now, look at where 5.5 lives. 5.5, did I do this table right? Yeah, 5.5 lives exactly halfway between these two. So we're actually going to use these two to estimate slope. Now, just as a quick reminder, normally these are x's and y's, okay? It's important because we need to, when you're doing slope, to subtract y's on top. So these are the always ones that go on top. So we're going to subtract y's on top. 150 minus 126, I did this, then this, now x is on bottom. Here x's are t's, so 7 minus 4. Now, we actually don't have to simplify this at all, okay? If you wanted to simplify this, you could subtract these and get 24, you could subtract these and get 3, you get an answer of 8, but you don't have to simplify it. You could actually leave this as your answer, but they do ask for units. So let's go ahead and find the units. The units, let's look at what we did. We subtracted these numbers on top. So we subtracted people on top. And on the bottom, we subtracted 7 and 4, which are hours. So this gives the people 8 people per hour. That's the rate that the number of people are changing at time about 5.5. Again, it's an estimate of the slope. All right, that's part A. Let me erase that. Part B is very, very difficult to put into words, but I'm going to do the best that I can. It's using the mean value theorem. It says, oh, no, part B is great. Never mind, I'm thinking of part C. Part C will be horrible. Use trapezoidal sum with 3 intervals to estimate the average number of people waiting in line. Okay, the number of people waiting in line is L of t. How do you find the average number of people waiting in line? That's the 1 over b minus a, integral from a to b, L of t dt. Now I told you that the average value formula is not on the AP exam, but right-hand Riemann sums, left-hand Riemann sums, and trapezoids are all on the AP exam. So we still have to know this stuff. Okay, so in this problem, again, this would be the average value of the people. So 1 over, and they say the average number of people during the first 4 hours. So first 4 hours, so it's 4 minus 0, integral from 0 to 4, L of t dt. Okay, This 1 over 4 minus 0, I'm going to replace with just 1 over 4. And now we're ready to give our answer. So, they ask us to use trapezoids to help us get the answer. Now, what does the trapezoid help us find? The trapezoid only helps us to find an estimate for the area underneath the curve, meaning it's only going to help us find this. It is not going to do anything with the 1/4. So my answer starts with a 1/4 times, and now in here we're going to use our trapezoidal. Really quickly, when you're doing trapezoids, our trapezoid formula, just so you guys know, is 1/2 height, base 1 plus base 2. And we're going to be using a couple trapezoids here. So we're going to use a trapezoid here from 0 to 1, here from 1 to 3, and here to 3 to 4. So our first trapezoid, it's 1/2 the height, base 1 plus base 2. I'm going to leave some empty space. Our second one, 1/2 height, base 1 plus base 2. And our third one, 1/2 height, base 1 plus base 2. Okay, so for my first trapezoid, my height is how far are these apart. So my height for my first one is 1. My height for my second one, how far are 1 and 3 apart? That's 2. And my height for my third one, 3 and 4 are 1 apart. So that's my heights. And now I need my base 1 and base 2. Well, when this is the height, I use both of these for base 1 and base 2. So 120 and 156. And then here we have 156 and 176 for the second one. And then the third one's going to have 176 and 126. Okay, and there's your answer. We do not need to do anything else. So that's it, and we're done. They don't ask if it's an under or over estimate. If they did ask if it was an under or over estimate, it would depend on concavity. Concave down is an underestimate. Concave up is an overestimate. You don't know what's on your quiz, so anyways. That's it. That's the answer to part B. So part B is over, and now part C, the part that's no fun. All right. So part C says, for 0 to 9, what is the fewest number of times in which L prime T must equal 0? Okay, now what does it mean if L prime T equals 0? Now, this means the slope, remember the derivative of the slope, is equal to 0. Now I'm just going to do a quick little graph here. I'm making it up. 0, we're at 120. By 1, we're at 156. By 3, we're at 176. This is at 3. At 4, we're down to 126, and then we're up to 150, and then finally at the end we're down to 80, and then 0. Okay, so I want you to see this. Now, first of all, slope equaling 0 occurs at maxes and minimums. Okay, this problem does not have any sharp turns. If you read the question, it says that the function is twice differentiable, meaning the first and second derivative both exist. So there's not going to be a maximum with a sharp turn. If there was a maximum at a sharp turn, this wouldn't even exist. This is not a scenario that can occur. So when they want L prime T to equal 0, that can occur when you have a min or max. When there's a min or max, you will have a slope that's 0. Now, just so you can see, I don't know exactly where this stuff is going to have these issues, but can you see the graph goes up, and then eventually the graph goes down. It goes from here to here to here. It goes up and then down. Now, I don't know how it gets through these points. It could go up and then down. It could hit a highest point here. We don't know where it's got to hit the highest point, but the idea is for a graph to go up and then down, it's got to have a slope of 0. Okay? So there's got to be a slope of 0 somewhere here. Somewhere between this 1 and this 4, the graph goes up and then back down. There has to be a slope of 0. Now, how do we prove there has to be a slope of 0? And again, this is a hard question. Hard question, hard to get points. But we're going to go ahead and give it a try. So how do I get points and prove that there had to be a slope of 0? Well, I'm going to use the mean values theorem. Remember what the mean value theorem guarantees. The mean value theorem guarantees slope, okay? So if a function is both continuous and differentiable, it guarantees that if I know the slope through these 2 points, somewhere between A and B, there has to be a slope that's the same as the slope through the endpoints. So look at this. Look what happens if we go between 1 and 3. Between 1 and 3, if I try to use the mean value theorem, so I'll say L prime C, and if we find the slope, if we subtract the y's on top and the x's on the bottom. I don't know what the answer is, I can work it out, but here's the important thing. It's greater than 0. And this is for some C between 1 and 3. So for some C between 1 and 3, we're going to have a positive slope. And that makes sense, the graph is increasing. And for some C between 3 and 4, well, let's look what happens between 3 and 4. So now when C is between 3 and 4, if we find the slope, 126 minus 176 over 4 minus 3. I don't know what I get, but I'll notice I get a negative answer. So let's look at this. The slope is greater than 0, and then the slope is less than 0. So L prime C had to equal 0 for some C in between. So this was from 1 to 3, and this was from 3 to 4. So somewhere between 1 and 4, L prime C had to equal 0. Now, that is a mouthful. I understand that. Great. And I only proved it had to happen once. Okay? Now the answer is twice. And I'm not going to finish the second part, but it's the same process, but it goes from 3 to 7. If you look at the ordered pairs, from 3 to 7, the graph goes down and then back up. Oh gosh, it happens a third time. Oh my word, this is insane. So you'd have to do this process 3 times. I don't even know how they expect you to do this. But the idea here is the graph goes down and back up. So down and then back up, there has to be another slope of 0. So we knew from here to here, there had to be a slope of 0 somewhere. That's the first one. From here to here, there had to be a slope of 0. And then lastly, look at this. It goes up to 150 and down to 80. So somewhere, and we don't exactly know where it's going to happen, there has to be a slope of 0 again. So using the mean value theorem, you can see it takes a lot longer. I think if you look online, there's 2 options. The second option is at least slightly simpler. I hope the process makes sense, though. You show if a graph goes up and then down, the slope has to be 0. All right, let's be done with that part and go to part D. By the way, there's nothing quite like that on your quiz, although you might have a mean value theorem. So make sure you understand the mean value theorem. There might be a intermediate value theorem as well in IVT. All right, the last question says, the rate at which tickets are sold can be also modeled by an equation R of t equals 550 t e to the negative t over 2 tickets per hour. Based on this model, how many tickets are sold by 3 p.m.? Well, how many are sold by 3 p.m.? Well, just the area underneath. Area underneath the rate gives the net change in the antiderivative from time 0 to 3. So this right here, these ordered pairs basically came from this graph, and they basically want to know how many tickets were sold, so the area underneath the rate will give you the net change in the antiderivative. You would type this in your graphing calculator. However, in the AP exam, there's no calculator required. So if they gave you something like this, you would either be able to take the antiderivative by hand and plug in the top and bottom and subtract, or they would say set up an integral only that would find, and that's done. But if you did type this in the calculator, you would get 972. They say to the nearest, so 972.7 would round up to 973 tickets. All right, hope you like parts of that question. I think A and B are really good, especially for your quiz coming up. All right, bye.